Hello and welcome to Automat Live Coding. On this stream we are writing a game automation app called Automat, which can record simple macros when I can move my key, and I can play back this macro and it's going to move the mouse for me. In Automat it's possible to connect the objects the pieces, I should call them pieces, that you can see on screen into sequences. So it's easy to do something that happens every half a second. Or the movement that I have just done, I can maybe get rid of the mouse press and create a loop that will continuously move my mouse in this fashion. And it is getting hard to move my mouse. It's jumping like that, so I'll switch this off. Recently, we have been adding a completely new orchestration system to Automat. So far, Automat had two ways of coordinating work. One of them was just a sequence, like one object, one piece executes, like it does some work, and then it calls another object. Like here, I could connect multiple of those timers or some other objects. Like I could, for example, press a mouse button every half a second, hold it for 10 seconds, and then maybe release it. This is how I release. So this is one way of doing this. The other way is through arranging object execution in time. This is something that can only be used through macro recorder now, but it gives you the possibility to move other objects around. You can record even those very fine, maybe I'm zooming too much, very fine motions, right? So this allows you to schedule something that's not going to run continuously. It's going to send signals to other objects at specific points in time. Okay, we have two mechanisms. Nice. The new one, which is implemented already, it just doesn't have a visualization yet, is synchronization of multiple objects. So here's an example where I have a space key. I can synchronize, this is the option to synchronize the space key, for example, with this switch. So now when I press the space key, you can see that it's being pressed. Yeah, it is being pressed nicely. It flips on this other switch. And this other switch, it can do stuff, right? I can connect this to something. So I can, start a timer when I press space. The timer only runs when I hold space. It could be useful for something, I don't know. The nicer thing is that if you connect multiple objects that can... This is not the best one. This one. So this is an object that can press left mouse button. I can also connect it like that. So now when I press space, it actually presses my left mouse button. It works in other apps, yeah. So now I hooked up the space to left mouse button. It's very simple. It's just one motion of mouse. I right click, select sync, connect it to another object. Now they are synced. Now, the problem is we cannot see those connections. This is something we'll rectify today. We already have a little bit of a design. So let me show you what we designed during the last stream. Those images, sync. Okay. So on this picture, you can see roughly how this system is going to look like. It's going to look more and more like the Incredible Machine game. I think the specifics of the visual design is something that we will figure this out once we are in Automat. But there are a couple different kind of elements here. So the central gearbox, this is the shape we are going for. So the first thing we will do is we will try to emulate this shape. And we will try to emulate it in a shader, not as a vector shape, as a shader. Or maybe it should be a vector shape. Yeah, to figure out. Okay, so this is the shape we are going for. This is the material we are going for. We could have plastic gears. They would actually work quite nicely with the rest of visual design. Those gears... Actually, maybe plastic is not such a bad idea. Whatever, let's go for metal. We will have something metal shaped. This metal, if you probe the colors, you will see that the colors are actually quite varied. This is... like, there are multiple variants. This is a much warmer, much brighter color. Shadows are colder. Anyway, this came from AI. AI is very good, like Stable Diffusion, is very good at color science. So let's steal from AI. Today, the goal is to create a new type of object which is going to appear in the center between those synced objects, and it's going to look like this kind of gear, but made out of metal. And think... So this is what is happening when we connect objects. So we have this thing called actions. This is part of the GUI library that we have. When the action is destroyed, that means I am lifting a finger and connecting two objects. A distractor is being called. This is probably, from the software engineering perspective, a bad idea. Distractors shouldn't be very complex. Distractors are a tricky topic in C++. They have a lot of sharp edges. If something goes wrong here, yeah, distractors shouldn't throw, they shouldn't do heavy work. Okay, so in Automat there are like two different layers to everything. There is the computational layer, which is just objects doing their own thing during the computation. And above them there is a UI layer. And the way they are synchronized is undefined. Like every object has to make a decision what is the most optimal way to render the object. For many objects, the rendering layer to get the most performance out of them would have to poll the memory. So the rendering thread would literally have to constantly check the memory of the objects which are being rendered to see if they have changed. A very battery intensive and work intensive approach, but this is the, let's say, unintuitively, this is the most efficient one. Not in terms of power efficiency, but in terms of letting the computational thread do its own thing without any concurrency primitives. Because the CPU will synchronize the memory eventually. So it's like we're getting synchronization for free. This is very rare. I don't think many objects actually rely on this. Maybe a couple of them rely on this. But this is not a common thing. Most objects in Automat, they actually have a special method called wake widgets animation, which tells the rendering layers that, hey, this widget has something new to render. Which brings us to widgets. Widgets are like shadows of objects. So every object, which is somewhere in the memory of a computer, can have widgets. And the widgets, they are connected to the window, which is rendering the state of Automat. They are single-threaded, kind of like JavaScript. Not quite single-threaded. There is a very well-defined flow of... They can be parallelized, obviously, but they mostly run on the UI thread. Anyway, so this sync action is creating something called sync block. Sync block, this is the gear. This is the central object which manages synchronization of multiple objects. The state of multiple objects, when any of them changes, they send a signal to the central object and it updates all of the other synchronized objects. This sync block, it is a proper object in Automat. So I just need to make sure it is tracked by the root machine. Sync block, yes, this is an object, so it can have a widget. From now on, we will have to use 2026. Let me take a look. So I can call this sync here. I shouldn't call this nomen. Nomen is... Let's call this named. I need to update a couple of files. So when a new sync block is being created, I should... Yeah, I need to kind of register it somewhere. Or maybe I don't. I could go to renderer. Where do we... recorder thread, no. No. Shutdown, no. Pack frame, okay. So pack frame is a very important function in Automat. The UI thread, which is rendering the window, this is the function which is called every frame, and this is a function that decides what we are going to draw during this next frame. Yeah, it's pointless. We will be able to get rid of this soon. Unfortunately, during each frame we are constructing this widget tree. That's fine. I actually think that because each object that has some fields, it tracks the sync blocks, it has pointers to sync blocks. Maybe I don't need to put those pointers anywhere else. Maybe I can just rely on the interfaces. No, that would be very strange if interfaces influence the renderer structure. So maybe no, maybe I will not do that. I could, but I won't. It would be poor layering. There is a different thing I could do. I have this thing called machine fill children. This is more of a way to list child objects. I don't like the fact that objects are part of the machine, but connections, they seem to be part of a widget. Yeah. So I have kind of two types of root object. So one of them is called root widget, and this is supposed to be the top level widget, which is now governing the whole window. We have the black hole as a child, the toolbar, like zoom warning. Everything is here. So in terms of layering of those objects, let me think how the gearbox should behave. So the belts, they will have to be drawn over the object. This is for sure. And if they are drawn over the objects, so the whole reason we have this split between machine and root widget is that machine contains the things that are laying on the table, kind of. So when I pick something up, it is being removed from the machine. So when this object is part of the machine, when I drag it with my mouse, it's being removed and moved to a different place in the widget hierarchy. So there is a lot of reparenting happening here. Gosh, nice. And the same with toolbar. Toolbar is, because it's not part of this machine here, it's thrown below. So to design this, to come up with how this should work, I think I should know how multiple machines are supposed to interact, like multiple tables of objects. Am I supposed to allow connections between them or not? The machine had this concept of front panel. It's an old thing, maybe it's too much to explain here. There was this idea that when I have a machine like that, I will be able to designate some of the objects to the front panel, let's say. And then I will be able to kind of zip the whole machine into a tiny, compact object. And the point of front panel would be to be the visualization of this machine. So I think the idea here was that connections would not cross. Between machines? Not sure. I'm wondering, should the gear be tracked by the machine or by the root widget? I think it should be tracked by the machine. Yeah. Okay. So we are visiting with children in front to back order. We have this list of locations here. I really want to get rid of locations. Another issue that comes up is that objects like key presser could inherit from different interfaces multiple times. And each of those interfaces has a different pointer to sync block. This is interesting because dynamic cast, it would produce multiple base classes. Okay, let's just go through the interfaces which are listed here. So here I can essentially like walk through all of the interfaces I have here. Should probably also try to cast the objects to some interface. A bit of problem here. So when sync block is created, it's created in this function sync. I think this could work. So Okay, I need to have a proper constructor and destructor here for those widgets. Because the lifetime, I'm kind of responsible for tracking it. Or not, I'm not sure. There's some sort of garbage collection here. Whatever, let's just do it like that. I think I should deduplicate them now, because each sync block is going to be I could just add this sync block to children and be done with it. But this would lead to duplicates. I'm thinking how to organize the connections between objects that cross machine boundary. Okay, I think I know how I want to do it. I think each object should live in should belong to some machine. Machine will be organized hierarchically, and when I pick object, I think I should change how this works. I think object which is being picked up should create some proxy object in its origin machine, and that proxy should then be connected to the stuff that's dragged around. Okay, so if this is the case, then I am safe to assume that there will be no connections to objects in other machines. Bold assumption. Okay, so sync blocks, they are going to be rendered in front of everything. And I think this should already work. It will not draw any gears. It will draw some placeholder rectangle. But this could work already. So, sync. Look at that, sync block. It's here. I cannot drag it. Yeah, when I try to drag it, it fails. It crashes. Nice. Super nice. So I am adding those sync blocks without locations. This is maybe you can get rid of locations for this new object type. Let's see. When I run it like that and it crashes, let me see where it crashes. I think I can just update a couple of... So a lot of the places in code, they assume that each object is owned by a location. So each object widget has a parent location widget. Very weird setup. Shouldn't be like that. This and this. Maybe let's synchronize just two of those buttons. Oh, I have a sync block. Now I can move it. It will crash, right? That's fine. That's fine. I can debug this. See where the crash is coming from. Should run. It is very slow. I should optimize this. It is very slow because the debug build of Automat is just huge. 700 megabytes. Don't worry, it's not as large in release mode. In release mode, it's 60 even 60 megabytes is too large. Probably be a third of that. Come on, okay. This is the debug build. Synchronize two objects. See, we get a new sync block here. The coordinate 0, 0. And now, when I grab it, there is a place in the code which assumes that the parent widget is a location. Or not. I don't know. Apparently it's not assuming that here. Make widget. If I am pressing the left mouse button, I am searching for the closest location. Not work like that. I will fix this. So move option. This move location option. So I think it works because even though this object here doesn't have a parent location, but it has a parent machine, and that parent machine, interestingly, has a location as its root. I'm not sure why it doesn't work in a release build ever. I will do this differently. I will do this location search. It should give me location pointer. I want to see if this is what was causing the crash. If we were trying to move something that doesn't have a parent location. I can get rid of locations. It's going to be amazing. No parent location, yeah, and it's not crashing anymore. Ooh. And I actually wonder, in the debug build, also the case? Because debug build was not crashing. Maybe some... I know. This is the curse of debug build. They are more stable than release builds. Yep, no parent location. Cool, cool. This drag location action see, there is a lot of machinery here for dragging locations. You know what? We will do this on Monday. Today I wanted to do the drawing of the gears, so and we can do this already. I think on Monday we will do location apocalypse. We will get rid of this class. It's going to be a big task, but yeah, I wish we can do this in a... If we can do this in a single day, it's going to be amazing. It's probably going to take more than that. Locations are everywhere. I shouldn't be using debug build. Release build is much faster for development. A weird word. Okay, so I can do this thing and see it here. We want to draw a gear here. That's the goal for today. Instead of this rectangle, we want a gear. Save this. Of course, I will have to repeat the sync because sync is not saved yet. I need to do sync each time. See how the sync block looks. That's fine. Let's go to interface SSH and add this make widget function. Not find widget, make widget. Object widget base. Okay, now we have something that we can use to control how we draw this. So let's start with shape. Shape is going to be tricky. Do I want to model the whole gear precisely? Maybe it should be drawn as a simple circle. So it's going to have center 0 and radius 1 centimeter. See how it looks. I'm basically overriding, so the green rectangle that we've just seen, I'm basically overriding this class and slowly replacing functions I want to replace, starting with shape. Yeah, it is a circle. Drawing code is not really ready to draw it correctly, so we will fix that next.
Cario 1995 says,
"The project seems really complicated but fascinating."
Yeah. Complexity is something I'm fighting with. This is the hard part of programming. Actually doing this without making it more and more tangled. Yeah, I'm not quite happy with how it works, but I think over time it will get better. So as the project matures, some things get more clarified. I think early on it was very, I didn't know how all of the things should fit together, and this is getting cleaner and cleaner. So I'm slowly removing parts which are deprecated. It's going to get better. Centered at 0. I think I should return true. I have no idea what this function is, but it should be const. What other functions I can override? Draw. I need draw function. This is the important one. Draw. Yes, there it is. Drawing in Automat is, luckily, super easy. So all those crazy class, this crazy boilerplate where I return widgets for each object, where I have to find their shape, it all goes away when it comes to drawing. This is actually very simple. I can create paint, which defines how am I going to fill the shape. Yep, and call this, and that's it. It's done. And the widget is being drawn. Now, the magic is going to happen inside this paint class. Now it's just a black circle. Let's put a shader here. I think... Where am I using shaders like that? Shaders. Quantum realm. Let's find where. This is the most recently written shader. And should see how it's supposed to be used from this. Yeah, this is the block of code I wanted to copy. This tells how to properly compile and configure a shader so that the paint actually draws with a shader rather than a flat color. Include embedded. We will compile a slightly different shader here. I will pass a time uniform. For fun, let's do rotation, alright? We can do or maybe I shouldn't pass time as a uniform. Maybe I should just rotate this funny gear. Yeah, whatever. We'll pass time. And this we don't need. Sampling, yeah, we don't need. So you can see the actual code to draw with a shader is actually much simpler. It's not much really here. Actually thinking that maybe I could have my own builder class for simple paints that would maybe avoid this. I cut maybe 4 lines of code from here. And then without this. Now this will compile. This could crash at runtime because I'm not setting all uniforms. Who knows? Look at that, it's not crashing. It's not drawing anything. Yeah, this is a different effect. This is a way to limit the zoom. Sometimes maybe we can put something in here. Still don't know what. Like when you zoom in too much, what should happen? This could be used for something, I don't know what. Okay, our gear. This circle here, this is going to be the gear. We just need to add the shader. Let's call this gear.sksl. The main function, blah blah blah. our gear is going to have one uniform call time. It's going to be the same as this one. Let's just copy this over. And here I need to change shader to gear shader. Now the circle should be red. And this is because now our shader is deciding the color. And we can use this local chord, this is the position, to draw a nice wavy function. Okay, I will do a short break, be right back. Let's continue. I had a bug automat running in the background. Okay. Let's look at this gear. This is the shape we are going for. We need two things. We need the angle, and we need the distance from center. I think if you have... I'm wondering if we truly need the angle. Yes, we do. Yeah. It hurts to develop like that. I think something like shader toy would be much faster, would have much faster iteration of loop. Expected semicolon, yeah, because of those issues. So 0 is here, it's going towards 1. So this is pi, this is minus pi. Looks fine. Looks decent. I think this length I will scale it because this length is going to be tiny. It's like 1 centimeter, so this is 100. So it's here. This division is going to be replaced by the compiler with multiplication anyway, but it's easier to read division. Yeah. So now we have distance in the green channel. Okay, looks good. Let's say the radius is 0.9 plus 0.1 times sine of angle times 2, something like that. There is a glitch here in this region. This is because we are not returning pre-multiplied alpha. I think they assume we will do pre-multiplied in the shader. Maybe it's possible to control this here. Options. Not sure. We could fix this by putting alpha here. This is how you do alpha blending with pre-multiplied alpha. What's wrong? Okay, now the artifact is gone. And we can change the scaling factor. So now we have 2 periods per rotation, and it causes egg-shaped gear. This is actually a gearbox. This is a proper gearbox. It just has 2 teeth. So it looks like an egg. Let's change this to 3. Maybe this should be even, I'm not sure. Oh, yeah, this is a 3-teeth gearbox. Looks kind of nice, actually. And the gearbox that we had in this design had, let's count, 14 teeth. Let's see how it looks with 14. Those teeth, they are not circular. I could make them circular, they are sign-shaped now. I think this is a very pleasant shape. It's not mechanically optimal, because mechanically you would want to have a surface, a flat surface, so that the forces can transfer perpendicular to the rotation axis. But it looks pretty. Okay, there is one more thing I want to do. I want to also check whether okay, maybe there is a better way to do distance. Let's actually do this as a height function. I would like to store height of this gear, and if the height is below 0, then it's going to be transparent. And I want to have height because height would allow me to have normal shading. I could use neighboring pixels to get normals. Or I could just do the derivative of the height function to get normals. Temporarily put height in all channels. I'm not sure what I'm doing. This could look reasonable. Radius minus distance. I think I should scale this a lot. Okay, but this is roughly... looks decent. Like I said, I need to scale this. So this height, this tiny region here, this is what will allow us to do nice shading. Maybe 14 gear is too much, maybe 12. 14 isn't looking bad. And I think instead of using proper gearboxes, I will switch to timing belts. I've seen something called timing belts and I like how they look. It's going to be smaller. Anyway. Oh, and we can actually make it rotate if we just add time here. Okay, it's stopping because there is one more function we would have to override. But let's actually do this. Let's do this. The tick function. So this is telling the UI system that this widget should not freeze its animation. It should continue animating as long as it can. Now we have a rotating gear. It's going to keep animating. And it's actually animating in a fairly... It was a jump. I've seen a jump there. Yeah, there was a jump. I'm not sure why this happens. Anyway, let's ignore this. For now. So I will add a hole punch in the center to this shape. This is not a proper SDF, this is a height up. Yeah, now we have a center hole. This will be h above 0. Yep. Let's compare this with the design here. Let's make the center hole larger. And let's increase the steepness of the function here. Slowly starting to look like I want it to look. A tiny gear. Of course it's not going to be white. Okay, let's add the fancy wave here. And there is this notch here. You can replicate. Let's do this here. So this groove right now is very sharp. Move this out to 0.4. I don't want it to be so sharp. If I draw this function, I'm drawing. So the function looks like that. We are starting. So we're starting with 1. So this is how the shader works. We're setting h to 1. Then we are taking minimum of our wavy end function, which is clipping it at r equal distance. So here it will be so this is our r, and here is this. So we are adding a function that goes like here. So this is the outer edge. This r is actually changing. So this is a dynamic variable. This is what makes the teeth look like teeth. But from the perspective of a single pixel, it doesn't matter. Then we are doing something very similar to the center hole. We are taking the this is the opposite. It's not this. This R, and this is this. So we are taking distance, should be a function looking like that, moving it down a little bit so that it touches this point in the 0.15. And we are scaling this up, so we have a function that looks like that. And here we are doing something similar. We are taking simple function this, which is a linear function, shifting it down by 0.4, which places it roughly here, taking the absolute value, so it looks like that, making it sharper. So this is our current function, how it looks. And if we look at this gear, we will see that this groove here, it actually has a much more subtle shape. It's something that looks like that. Is there a web app for designing polynomials? Oh. Come on. Whatever, we will use we'll use our own function. So this isn't exactly okay. Let's do this as a polynomial, like a proper polynomial. So this is what do you call this? This is a point where derivative goes to 0. You can probably say that the polynomial will continue like that. This is another point where derivative goes to 0. So the function will go like that. Then we also have this point here. This is also derivative going to 0. So let's try to draw this shape somehow. I'm actually not familiar with GeoGebra. Okay, I can do those things, nice. Let's say this point, I want it to be placed at 1. Okay. So this is our polynomial. Theoretically, actually no, it's not so great. I don't know how to design them properly. Let's get rid of this last one. I remember there was a way to do those fancy offsets. Oh. Okay. Yep. I remember. So let's start with the first one. The first polynomial is going to be 0 at 2 and 3. Okay. So this is first our polynomials. It's 0 at those points. It goes through 1 here. Plus. Actually, I will design the second one here. Okay. So the blue polynomial is 0 here, 0 here, and 1 here. This one has 0 here. So it should have... No, it's perfect. I should just be able to add those two, right? Okay, so it is going through the right points, exactly kind of like I wanted, but they don't have zero derivative there. So this is the thing to add. So let's do squared here. Squared here. This is not working. This is not working. Do regular math. Or I know what. This is time for DeepSeek. Okay, we want to have flat derivatives at all 3 points, and the value should be 1, 0, 1. And we will be able to move those points around if it finds a nice parametric function. There is a way if I was able to make it so that this function would actually be flat at this point. Instead of just going through this point. For math. Let's try other AI because this one's kind of slow. Let's say x1 is 1, x3 is 3, x2 is 2. Looks sweet, super sweet. This is what we wanted. DeepSeek is still thinking. Not sure if this is a polynomial. Okay, those are constant, so that's fine. The only thing which is a problem with this polynomial is that I would like those points at the edges to escape to infinity. So like that. So this is a controllable notch. there is this darker region here. Something's wrong here. Looks like the solution from Gemini isn't actually correct, because here the derivative is not maintained. Yes. It doesn't look correct. Maybe I made a mistake. X2, X1, X2 minus X3. Yep, yep. Yeah, this is what I thought. Solution has to be slightly more complex. I'm pretty sure this is wrong. Okay, this is why you shouldn't trust AI. And again, it's repeating, it's not actually using its own function here. It's just looking at my task and saying, oh yeah, it's correct. This is a more believable function. Maybe I will have to rewrite this differently. Actually, let's see how H1 looks. It's going to be interesting. This is a fancy shape. Change right 2.8. Oh yeah, I wanted to lower this. Cool. Let's do the second part. First part isn't looking bad, actually. Okay, so it works nicely in the sense that it really satisfies my conditions. But unfortunately, outside of this range, this function isn't quite what I wanted. It goes right after it reaches 1, it starts going back to 0. So it's a nice shape. Maybe let's do this. It would be more elegant if this actually went to infinity at the edges. Maybe I can actually ask the model to make a function that goes to infinity like that. Yeah, now we have a nice, super nice edge here. Maybe it shouldn't go completely to 0. Let's do it like that. Something is wrong here. You know what? Maybe I will just do smooth step. Yeah, this is definitely not going to 0.7. Smooth step is a polynomial, right? There we go. This is kind of what I wanted, really. There's one more thing that I think I will add. I think I want to add a slight roundness, this whole gear. So instead of starting with 1, something like that, I don't know. So it's going to be thick in the center and the height is going to decrease outwards. Actually, no, smooth stuff is bad here. At this outer edge. That was way better. I'm thinking, I like this edge here, but this edge, this outer edge, very sharp start. Is there something like smooth step, but with vertical start? I want to shape this like a circle. Let's do alternative center hole with slightly different math. I have no idea what happened here. The gear looks nicer. This is not what I want. The distance is 15, something like that. Rid of this outer teeth, rid of this notch for a moment. Oh, this needs to be squared. It's actually looking decent. Times 15 should be somewhere else. Now, this is a really nice shading, but not the goal, not the goal. Cool. This is what I was looking for. This donut shape. Finally. So what control do I have here? So this distance is how far the center of the donut is located from the start. And I think this controls the radius of the donut. So this is how the center hole looks like now. It has much nicer profile, rounded profile. It's not a linear chamfer. I think I will do something similar here. So this will create a ball, like a ball-shaped gear. It's not what I'm going for, but it's an interesting starting point. Ball-shaped gear. I can flatten it. So only half of the height is going to be circular. So this is our gear height map. Now this height map should be converted into a nice... we should basically color it and add some shading. Fine. I did remove those of code, that's good. Sync function has been moved out. Ooh. Remember, during the last stream there was some bug with the direction of synchronization, but we'll look at this in a moment. So I am committing this because I want to engage some AI to help me with shading. And let's help the AI and let's give it some colors, like some example. Can I do this? Let's convert image. Okay, I can just paste it. Sometimes it's doing weird stuff. It's angle 2, it's the same angle. It's angle 1. Why is it recomputed? Mouse. Yeah, this code is usually bad quality, but often works. So let's see if it works. Totally not what we wanted. The colors didn't match at all what we wanted. It hurts. It hurts. Normals look kind of good. I mean, except it shouldn't be so sharp. Let's go to this. It basically removed comments. Great, great. I think the epsilon could be too small. Maybe this is what's messing up with the smooth step. Yeah, because it shouldn't be so sharp. Let's increase the epsilon 10 times large. Now it looks cooler. Something is wrong here. I think I could do this scaling outside. Yeah, now it's looking better. Still a little bit sharp in the corner. Make that higher is delta. Something is very wrong here. have a really nice smooth edges. What's up with this? Maybe the epsilon is too large now. I guess it is. Hey, totally. Yeah, this should be a smooth curvy edge. Can use the FDX. Let's try those. I just want to avoid those functions if possible. They tend to cause problems. Super cool, but they tend to cause problems. Like those. Yeah, they cause problems because you can see when I zoom in, the normals disappear. When I zoom out, they appear back. This should be fixable. I just need to divide this. And see, now I can call this 3 times less, basically. Still disappearing. Let's bring back the normalized version. And see those normals. They are pixelated. This is because the GPU computes those values in groups of 4 pixels. And this can be used for easy normal calculation. It's always going to be pixelated like that. I have no idea why those normals here don't make any sense. This edge is a smooth curve here.
Meister Chica says,
Hello.
Hey. This is an interesting effect. This is a numerical derivative along the x dimension. But I wanted to calculate it so that I can see if this edge is actually soft. It seems to be soft. For some reason, normals are not softly curving along the edge. They are behaving as it was a sharp linear bevel. Here, I could even live with the pixelated edges. If at least this was correct. Now it's suddenly softer. Okay, now it's super soft. Why? I don't know. I have no idea why increasing this value makes it behave correctly. Yeah, this is how it should look. Maybe this is even too sharp. What if I skip the normalization?
To minify or not to minify JavaScript for website to...
It's not a hard question. If you have something to hide or something to compress, I think minification usually hurts you more than it helps you. Even for development, you know, it's like wasting time. You cannot just hit F12 and fix stuff. And you also have to invest time in the minification itself. I think I know what could be going on. So this is the version which looks good at correct distance, but when I zoom in, it stops being good. I think maybe here. This. This fixed the scale problem, but we still have the rough edge. This is something that would happen if this was actually too small, this value here. I get rid of this normalization.
ZT says.
In the Summertime is a tune.
Yeah, it's nice. Okay, I think I know. I should just compute this z value differently. So this will be minus dh, this will be just 1 minus come on. It's very strong, but maybe it's not so wrong. At least it's scale invariant now. don't know, 20? This is the problem. Should I just divide it by more? I have no idea what's going on here. Why are the coordinates wrong? It still has a sharp edge here. Go back to this version. It may be by the length of the chord or length squared. Maybe this is what will fix it. Now it's even sharper. We can see the depth, but it's way too much. So now it's scale invariant. That tells me something is right here. It feels scale invariant. I'm looking at a single channel. A single channel should only reach maximum in a single point in this whole gear in the red channel should only reach maximum here, maybe on those edges here. Actually, not even there, only here. And it's reaching maximum basically almost everywhere here. This is way too large. So maybe this is still too much. Maybe somehow this is messing this up. They should divide by 100, I don't know. The advantage of this, like this super flat image, is that at least the edges here seem correct. Something fishy is with this. There's something fishy with this normalization. Now this looks great at this zoom level. This is kind of what we should have. When I zoom in, it stops being so nice. Let's get rid of local code. Let's replace this with unit code. Now it's completely gone. Should have been multiplied. Yeah. The gear was there, it was just very, very small.
(772) says,
Hello.
Hey. This should be called UV, basically. Stuff here. So wrong. Let's actually call this UV.
It turns out that reality is whatever we make of it.
True.
I am on Earth to eat, drink water, keep everything tidy, and talk to people.
The purpose of life. Why is this channel maxing out so quickly?
In the process, I'm going to build things so that we can do this together.
It's an interesting philosophy. The starting point is especially interesting. We're starting with satisfying needs and socializing. And then you talk about engineering stuff. Looking at this shader, I think we check the RDX. What is the definition of the RDX? Okay. So this is actually... Oh, I can use DLTX, DLTY, fine. This isn't caring about what I put here. It's caring about window coordinates. So I think actually scaling is the right approach. Be more. It's still... I should actually use Corpic. Get this. That half.
Is this a new component? What does it do?
This thingy here. This is going to be the visual representation of two objects synchronizing their state. So I just synchronize the state of space with this thing here. It's not hooked up anywhere, but this is going to be the central component. So from this button, there is going to be a belt drive going out and connecting with this gear. I think the gear will be smaller. I will make the gear slightly smaller. And whenever I press space, the belt drive from space is going to push this gear, and this gear is going to push this yin-yang icon. And the gear and the belt drive, they are going to be the main way of controlling the synchronization mechanism. Right now this is done through the menu. I can do monitoring, sync. Anyway. So this is just a new widget, a new object that will control synchronization of multiple objects. Like the mouse buttons. Now I have a space that controls the mouse button. So the mouse button is also going to have a belt drive going out that connects to this gear. Some colors. It's actually fairly reasonable. Yeah, kind of pretty decent. Maybe this is the correct normal. Large.
Virtual vec is definitely not the similarity metric I use in my mind, insofar as I use one. I've been getting the words wrong of late.
Yeah, word2vec is really... For each word, it tells you what the context for this word is. It's not... Actually, now this is looking kind of nice. It's normal map. This is what I should be doing. I think this is nice. This is the correct one. Okay. Yeah, word2vec is also telling you something about the document where the word was is typically found. It's telling you not only about the word, but the neighboring words. Yeah, I think this is a nice normal. Okay. Let's roll with this. Instead of chord, let's call this UV.
Command-L is a fun way to train broad cognition, though, seeing patterns between topics.
Yeah, I guess it's good at kind of making you better at IQ tests. Okay. So now we have gear normals, and I did something questionable. Let's see. This class here, static asset also here. This const thingy. So really what this struct is doing, it is bypassing a limitation that we have where there is some undocumented feature within Skia that we want to access, and this is the only way to access it. It's to change this private thingy. Maybe I should enable this as well. It looks like a cool feature. Like this frag chord. I could actually avoid one derivative in the shader if I had access to this variable. Some built-in functions, I guess, are here.
Didn't know Chromium used Skia too.
Yeah. Chrome, Android, Fuchsia. React Native also is using Skia directly. React Native is actually one of the contributors to Skia that I like very much. They're actually adding new stuff here that's making it possible to get new effects. Color conversions? Okay. Okay, lab.
How about directly controlling pixels on screen?
Sometimes possible, but very rarely, like usually on embedded hardware. It's possible to map some GPU memory into your virtual memory, then you can access them directly. It's rarely done, very rarely.
So does Skia provide abstractions to make manipulating pixels easier? And give structure and model to visual representations?
Yeah, like the thing that you mentioned, accessing pixels directly, there is a mechanism in Skia. It's actually even older than Skia. This idea was taken from much older APIs of locking, pixel buffers. So if you have a window, it comes even from Windows 90 something. This is how old it is. You're basically calling a lock function, and the lock function gives you a pixel buffer. You can do something with the pixel buffer, and then you call unlock, and the operating system takes the pixel buffer and makes sure it's displayed on screen. Behind the scenes, it can be super cheap. It could be just a pointer, It could actually be in-place modification. But on many modern devices with a GPU, it actually involves copying the buffer from the GPU memory and back to the GPU memory. So yeah, you get access to all of those nice primitives that allow you to, if you want to work with pixels directly, go ahead. If you want to work with shaders, you can do that. And if you want to draw vector shapes, that's also there. It is a very multi-paradigm graphics library. It's not opinionated in any way. It tries to be very general, and it's very good at mapping Vulkan, which I really like. So in Vulkan, you structure your drawing as a sequence of steps where you have a texture. You draw something to this texture, and then you use this texture to draw another texture. And it's a long graph of textures which eventually displays the texture on the screen. It's nice in theory, but Vulkan is such a pain to work in practice. Constructing this graph it requires you, it's a very low level API. You don't really work directly with this graph, you work with much lower level primitives like semaphores and command buffers. So what I really like about Skia is that it can do all of this for you, but it still exposes the entry points where you can kind of hook up into this Vulkan graph and inject some of your own magic. It's super cool. Fascinating. Sparse morphology. Morphology in image processing is about changing the shape of objects. It's not a linear operation. This is something that messes with the shape of objects. So many interesting private functions. Okay, I will just see if this still compiles. I wanted to, now that we have normals, I wanted to try AI again and see if maybe now it will be able to pick them up correctly. Okay, still there. Góry normal map. New thread. Select this gear. Copy.
Since many things rely on electricity, do you think there are people working on keeping the electrical grid reliable 24/7?
absolutely. I was even able to meet some of those people. There is a whole ecosystem about, electricity. I guess it works differently for each country. In my country, there is, for example, one company which is a government company which intermediates between different energy providers and makes sure they are able to deliver electricity everywhere, and sometimes they even buy some electricity from outside of the country. And they are responsible for maintaining the grid, the shared infrastructure.
Are there enough intelligent people doing this?
I would hope so. When I... it's actually a very small number of people, but they are definitely competent enough to make sure it works. It's fewer people than you would think. Like, most people actually want... in those energy companies, they work in like customer, closer to the customer. Office workers and so on. But yeah, this is actually a very nice place to be in the energy sector.
Many people seem to only be concerned with getting a job and aren't necessarily interested in keeping our societal system stable or even care about it.
Meister Chica says,
For that one, you can blame natural survival system.
772 says,
So, I want friends who are actively involved in this kind of stuff so that I feel better.
There is a place to meet them. This is conferences. Sometimes on software conferences, especially the business-oriented ones, they are really not about software, but about companies trying to recruit programmers. You go to any one of them, they will have something like 100 booths with different companies standing there and, showing why they are the nicest place to work at. If you're looking into meeting people from a specific industry that you have no connection to, this is probably the best place. They're not quite trade shows, they are conferences. Tiny conferences, actually not so tiny, but they usually have some talks, some facade of talks, but really it's about hiring people.
TP Chica, I still do not believe fiat money works. Having a hard time building over that abstraction. They say that the hand of the free market is invisible, but also blind. So I wonder if the same is true of societal infrastructure stability.
Nobody is in control. Uh, not fully, not fully. Those things are actually taken care of. They are not. Energy market is not a free market entirely. It's really well regulated. Allow this command. I don't want to allow arbitrary commands because it can do crazy stuff. I have no idea why it's computing angle second time. Or maybe it's a nice idea actually, do this second time. Oh yeah, I remember. There are actually some instructions that allow the, let's see if they still work, that allow the AI to take screenshots of Automat. So it finished the implementation, it has built Automat, and now it's running a special command that will start Automat and take a screenshot. I don't know if this will work.
Last semester, I made friends who actively worked in designing microarchitectures. So I feel better WRT computers.
Nice. So I will stop the model because it's using tokens and it's not going to actually do anything useful. Let's stop this.
Now I feel slightly better about graphics after seeing enough work on it. Ha ha ha.
Yeah, I'm not a game engineer. I guess somebody with the right experience would probably use slightly different techniques here. Okay, this is kind of crappy, but I think this is what's causing the problem.
Or at least use lower-level graphics libraries that I wasn't familiar with earlier.
Yeah. I would say this is a nice gear. It's slightly too black near the edges. I think I could fix that. Slightly too black near the edges and slightly too black in the very center where it ends. And how about light?
Could you make the gear 3'd in 2D? It'd look cool. It'd look cool. At a small depth.
Yeah, it kind of is 3D. This is just isometric projection and it's not looking... it is slightly 3D. I could rotate the light so it would be more visible then. Right there. If if I rotate the light, the 3D structure should be more apparent. I can make this faster. Let's make it 5 times faster. Okay, you can see there is light here traveling along this edge. There is the radial effect, which I think is making it harder to see. Yeah, now there is some light circling around this shape. Okay. I think the normal is still too sharp. Or maybe it's fine. I don't know. Anyway, light direction. I do not want any horizontal component here. The light should be shining top down. Mostly from the front. I think it's shining from the bottom now. Blah blah blah. Automat-based ambient occlusion. Yes, we do not want that. Actually, ambient occlusion should be height-based. I just moved the edges. I like the ambient occlusion, and it's true that height is the main signal for this. Maybe I can keep it. fairly sharp edge here. I'm using this DFDX compute normal. DFDX fine. Maybe will be more accurate. Let's see. No. It's not in Skia. Cool. I will try to work on those sharp edges now. I think the plan is alternative. Not quite the same color. This one should be colder. This isn't bad either. Whatever. So looking at this graph, I want to change this edge so that it's nice and smooth. Interesting, interesting. Not what I wanted. That's cool. Actually, this looks fun. Can we use that? Would be hard. This is how a belt could look, really. The belt that wraps around some object and goes to the central gear. Oh yeah, I forgot. Should be power. Yeah, should be squared. Something squared here. This is pretty much what we used to have now. Fancy gears. It'll be too fancy. Let me look at this graph again. I want to have something like that. Should be my height.
It looks more like a sunflower now, TBH.
Yeah. Nobody would make a gear like that. It is a fancy shape though.
Mechanical engineers are deeply offended.
Let's call this margin. So this distance here, this is margin. Love it. So margin. I can take r minus distance. So this is this here. I think I need to divide this by margin. Have it normalized from 0 to 1. Now I can square this. 1 minus take security here. And this should give me my height. Will actually this will be not a number most of the domain. Here, yeah, we do have a nice rounded edge. Actually, I think we want 1 minus that. Or not. Actually, no, we don't. This is a fancy shape. No, no, no. I need to understand what I'm looking at now. And what is going on. So I have... So along the center, there goes sine wave. This is R here in the center of this tunnel. I just figured out why it's looking like that. Okay. Wait, there are sharp edges here. There are sharp edges because I'm using rounded surface as a base. I use flat surface. There will be no no sharp corners, sharp edges there. Yeah, now it's super smooth. Center should be here. Ooh. Now we have super soft gear. So smooth. So smooth. There are no triangles here. It's just each pixel being calculated independently. But I want to have curved surface. So let me get rid of this. I think instead of taking minimum, I can do multiplications. There should not be a big difference between multiplication and minimum. now we have those sharp edges, but just do this, and the sharp edge should be gone. Yep. So nice. And do the same with other pieces. There's no sharp edge here anymore. So soft. Too soft almost. I've done. This rounded surface. Here, I just changed this initial height. Oh no, I changed the number of teeth. Yeah. We will make the whole thing more ball shaped. It's hard to see. Have to see that this gear is now shaped more like a ball because of this central and this groove around the center. Well, we lower this a little. It looks nice. There is one more thing that could bring it to the next level, and this is anti-aliasing around the edges. The fact that the edges here are black, it's not good. We should have, because behind we have white background, the edges should actually be lit on the background. Should not be very black. Same lighting. Let's make it stronger. Oh, rim lighting is multiplied by ambient occlusion. We don't want that. It's much more... This is glitchy, actually. Now, let's just remove the ambient occlusion from here. Rim lighting is actually a little too skinny. Let's lower the power here. So strange. So this rim lighting was kind of integral to the whole gear. The comments are absolutely not what is happening here. This Fresnel lightning is present everywhere. Yeah. I think let's get rid of this rim lighting, see how it looks without it. Make sure it looks good without the rim lighting, and then I will fix rim lighting. Anti-aliasing is the important thing though. We'll have to think about how to anti-alias this. Okay, without rim lighting is looking good. Nice. Should not be so blah. Edge darkening. Come on. We already have this ambient occlusion thingy. What's the point of doing this twice? Actually, this could be used for alpha.
I shouldn't have said anything. Haha. Haha.
Well, if you're referring to this mechanical engineers thing, they probably would be. The way to design gears is to have... there was this gear generator. Yeah, this is how proper gears should look like. And see, they are constructed in a way that the point at which the force travels is it's basically making sure that the force is traveling at a perpendicular direction to the surface. There is no grinding of the gears. Those gears, maybe they could work. I don't know. Sine has a lot of cool properties, but I haven't seen sine-shaped gears. Timing belts, they usually have circles in them. Actually, the type of teeth would indicate what data type is being synchronized by this gear. You know, booleans could have teeth, like on-off. Continuous signals could have sine waves.
So the gear teeth have flat separators. But Automat's gear wheels don't.
Yeah. They are not designed to mesh together nicely. The meshing has no particular... it's not optimized towards anything other than it's looking nice. It's edge darkening. I think this should give us 10 pixel anti-aliasing, if I haven't messed up anything. It's no anti-aliasing at all. Doesn't make any sense. use move step and hide for this, but yeah, this approach I don't like because it's giving transparency here, but aliasing artifacts here. Oh, it's length of a gradient for some reason doesn't work. Weirdly, alpha still seems to be very high. And there is a little bit of blur now. Now it's creeping over here. This edge, now it looks like it has a nice anti-aliasing. This scale, and this scale not so much. Maybe I can increase the height of the notch. Yeah, at this scale it kind of looks good. I zoom out, it should start to happen. So if I had a proper SDF, I could actually make SDF for this, I think. This is how a sine wave SDF looks like. Yeah, it has some discontinuities. Yeah, I think I will maybe leave this as a to-do. There's actually no point to have this as a smooth step. It will be basically the same function. It's a different, simpler function used here. Okay. Okay, specular should not depend on this ambient occlusion factor. And let me bring back the rim lighting. So this will give basically -1 on the flat surface. Or no, will give 1 on a flat surface. So 1 minus 1, okay. This is why we have this power here. Okay, it does look like a rim lighting formula. Now we can see that this red rim lighting is almost invisible. Maybe. I got here, I don't know. Not rim lighting at all.
See you later, Muff. Gonna work now.
Yeah, see you around. bit normal map. Maybe still too big, too deep. It's the only thing that could be messing with this rim lighting. And now it's not here at all. They compute this derivative analytically, maybe. I feel like that would be easier. You know, crazy things started happening with the shape of the gear. It's very glitchy now. Back to 100. Okay, goodbye, rim lighting. Or maybe I will just comment it like that. disabled. This looks crappy. I will keep it at 3. I'm not sure this brushed metal effect is really adding anything. It's just some, I don't know, high-level noise. It's hard to compare. There was a tiny difference. Hard to say what it was. Is this not used? Things I would like to improve. I would like to get rid of those derivative functions. The number that I'm getting here is totally broken. Let's get height. we have our gear. Now, this funny hide function. Take a closer look at it, and let's try to replace it. So the convenient thing about this function is that this dist, let's actually rename this. This dist is actually x. All of the dist functions, these variables that are in use. Okay, first of all, we have the top shell. And this top shell is looking like that. It's a flattened circle. Oh, the derivative should be sine x. Nice. So I am going to use the fact that we have the gear has a radial symmetry, basically. So this is the dh is kind of derivative along this line to find the final derivative. I will get and this normal immediately looks better than the one computed by the machine. This step by step. So the next part is really hard. The next part is where we do the edge, fancy edge. Something like that. I need to do the H2 now as well, somehow. Doesn't look correct at all. This side should be red. Maybe I should subtract. if R gets rid of this wave, then we should have a correct solution now. Only problem is this R. Yeah. And check this by probing some colors. Yeah. So good. I mean, the values are, they make sense here. Now, instead of doing this correctly, we can also try to do some weird magic. We'll basically play with this value until the shape of the normal looks correct. It's definitely not correct now. Shift this by say if this is correct. It's totally not correct, I mean, but if I'm moving in the right direction or not. Maybe I just need to do minus. It's weird, but it's not looking that bad. I think I need to multiply this by something like that. Close. I don't know why everything seems to have flipped directions. Oh, maybe instead of this, use this more. I'll do this. I should probably see more clearly what's happening. It's not looking bad, actually. Let me just see if the vectors point in the right direction. This one should be the opposite. The opposite, okay. Now those normals, they are absolutely incorrect. Absolutely incorrect. I just guessed functions. They should look nice when this is actually drawn.
Says, hello Alexstejka. This is a reminder that TTS only works in English. Please use English in chat. Thank you.
Yep, like you hear. So this is the new, and it's bad. It's already overshooting. Potential values. Whatever. Yeah, I guess I should use H to multiply this, to scale this. Not much better. It's not better at all. Anyway, at least it's smooth. There are no discontinuities in this normal map. You could even remove this early return and try to shade the gear using this new manually computed normals. Looking nice, looking nice. I could probably normalize this. I'm kind of guessing the functions, so there is no point being accurate. I will just put one in the normalize and it will give me some normal. Looks like a gear. This section looks flat, and this is because here we do not have normals yet. And will be fixed shortly. Sorry. now it's looking less crazy because I added normalization. Okay, center hollow. Center hollow should actually be simple because center hollow only affects DH. How did this work? I should take the old derivative. And multiplied by this. And now I can add the new derivative. Multiplied by h. Something like that. Maybe I will add minus somewhere so that it looks nicer. It's not the right way to work with derivatives. But look at that. It produces something that looks reasonable. And this should be mostly red channel. Yes, it's mostly red. And blue. Weird. It should be mostly negative green. Yes. Yeah. This. Because I know that at some places, how to compute Z. Actually, I can do this. So the value of DH, I am computing kind of good. This is actually close, the accurate value. I don't know how to compute DH2. DH2 is beyond my math skills. But yeah. Now this is a proper normal map. Here, the red value should go to FF almost. The others are neutral at 88. Here the red should go to 0, 0. The others are at neutral. Here the green should go to minus, to 0 and to 1. Yep. This is our new gear with the center notch. And you can see now, this is how it should look. Yeah, it should be smooth and shiny and yeah, perfect. And it should connect cleanly to the rest of the gear. I would like the same to be the case here. It's not entirely true, unfortunately, but like this. Something's wrong here. There should be a highlight here on this edge. and there is no highlight. Let's look at smooth step function. I think smooth step is basically starts at derivative 0, it goes to 1, goes to 0. It's basically like a full period of sine wave. Oh, actually I can do this. So this is 6x. Okay, now let's see if we can properly do this. How did that product rule work? So I need take the old derivative, so dh times the value of the function, so yeah, h, it's new value of the function, okay. I will finish this. How are we looking? Snow clamp. Sure. What's going on here? It's definitely looking interesting. Okay, so this is what we started with. So I'm taking this side of the derivative, scaling it. Ooh. It's not doing anything because there is nothing here. Ooh. So this second component, the notch, must be messing up everything. GeoGebra shows this indeed looks reasonable. Well, this strange thing is that the notch takes X.
Rocker Trader says,
How many bits to commission a deck builder game for my is that even something you would do?
Yeah, everybody's making deck builders. I don't do commissions, no. You can probably play with AI. Get Claude, like get the Claude Opus subscription and ask, literally write the design doc for the game and send it to AI. It's going to... It typically does something decent. What's up with this notch? So here is our derivative. I guess it's just very large. This isn't complete. This isn't complete because when I... This doesn't account for the scaling that I'm doing here. This scaling. Maybe like that. Just adding random code until it looks nice. Maybe it's good now. Still some weird things happening. It's looking definitely better. It's like it's going in the wrong direction. Okay. This is how a normal map should look like. See if the shading can actually work with this. So shiny suddenly. Sweet. And there are no issues with the blocky appearance anymore. The normal map is made up. It's not the correct normal map. And because it's made up, it can be tweaked to appear in a fun way. Like the depth of this thing, for instance, seems quite deep. Maybe it shouldn't be so deep, I don't know. Of this, is it going to be even worse? Oh yeah. Maybe I should square this. This is wrong. This is wrong. No powers here. I wanted to see what would happen if I just move this one line down. That would be wrong. It's looking fine, but it's looking nice. I think this one was better. More. Let's call it more accurate. I want to rename those DH2. What is DX? And this will be DY. Oh yeah, this is why it was too strong. I need to multiply this by 0.7. Better. I think now that we have correct normals, we can probably bring back the rim lighting. The crown jewel here would be if we had SDF. It's not impossible. That would be hard to do today. SDF would allow us to do anti-aliasing. Rim light. Bring it back. This will hopefully make the gear blend in nicer. It shouldn't stand out. It shouldn't have such dark edges. Too hard. The original was 0.3. I think it's okay. This is our gear. This is supposedly a combination of this, of those two gears, but now it's alive and it's part of Automat. Actually, the metal kind of looks right. It's not the same, but same style. I'm wondering about shadows. This gear doesn't cast shadows. Oh, I cannot take it out. Managed to. Okay. I think I want to fix the anti-aliasing. When I zoom in, it's not looking bad because I added this smooth blending, but when I zoom out, I'll start seeing subtle problems. So yeah, I think during the next stream, which is going to be on Monday, we will fix the anti-aliasing. Maybe we will try to figure out how to add a shadow here. And how to connect it to other objects. Oh yeah, and I also wanted to do this location apocalypse. Location apocalypse has to wait. Let's finish the gear. Let's add proper anti-aliasing. Otherwise it's going to annoy me forever. Yeah, well that's the plan. Alright then, see you next week. Bye bye.